So what we are going to do today is look at parallel and perpendicular lines. So far in our linear equation journey, we've learned about slope-intercept form, which is the formula that gives you the slope of the line and where it crosses the y-axis. Most recently, we learned about point-slope form, which gives you the slope of the line, but also just a random point. It doesn't have to be the y-intercept. And now today, we're going to use that information to look at parallel and perpendicular lines. Maybe in previous classes, in a pre-algebra class, you might have touched here and there with a little bit of geometry. You might remember what parallel lines look like, or maybe have an idea. Maybe you have an idea what perpendicular lines look like. So I just want to kind of brainstorm if anyone does remember what parallel lines look like, or anything about it. Does anyone here remember anything about parallel lines? No? Yeah? Oh, thinking.
Oh wait, I think I know how to do what the description says. With the calculator.
Oh yeah?
I think so.
All right, well, we'll save that for when we get there. But parallel lines, if I said 452 runs parallel to 352, which is true, I think. Yeah. In certain places, maybe not everywhere. But in certain parts of 252 and 352, they're parallel. What does that mean? Yes. So Bailey's going like this, which means she's putting her hands straight up. She's not explaining in words, but I understand what she means. What does this mean?
They go straight.
You go straight? Kind of like equal? Do those roads ever
They never
cross? Exactly. Lines that are parallel don't ever cross. Now, I need to look at a map, but I'm just like particularly thinking about them in a certain area. 352 and 452 might cross at some point, but they might not. Maybe they're totally parallel from start to finish. I don't know. But parallel lines are lines that never cross. If we look at this classroom, I have like these old school Ethernet beams and stuff, like with these outlets, because this used to be a computer lab. All of these beams are parallel to each other. They don't ever cross. Right? They're parallel, just like those rows that I explained could be. If we look at the ceiling, these ceiling tiles, if you look at the ones, like the beams going this way, they are all parallel. And then if you look at the ones going this way, they're all parallel. There's a ton of parallel lines in real life because most things that we see run either vertically or horizontally. So parallel lines are lines that don't intersect. And they never intersect for a certain reason, which is what we're going to learn today. Perpendicular lines are quite the opposite. Perpendicular lines do intersect, and they intersect at a certain point that makes them a perfect 90-degree angle at all four places. So looking at up here at the tiles is a perfect example. You can see all of these X's. Or plus signs, they look like these crosses at each time one of the parallel lines crosses with a line that intersects it. It intersects completely at 90 degrees, which makes it a perpendicular line. So in this chapter, we're going to learn about what equations look like when they are parallel, meaning they don't cross, and what they look like when they're perpendicular, which means they cross at exactly a 90-degree angle. So in this exploration, in a traditional awesome world, we would work with partners, but we'll probably be doing more like independent work today. For those of you in class, you can work with each other from the 6-foot distance, but what I'm going to have you do is write all 6 of these equations. So in letter A, you have 3 equations, and in letter B, you have 3 equations. I want you to write all 6 of these equations in slope-intercept form. Then together, we're going to use a graphing calculator. I'm going to show you how to use one to put them into the graphing calculator to see what they look like in graph form. So remember, slope-intercept form is not what we just did for our warm-up. Slope-intercept form is this: y equals mx plus b, where this is the slope, and this is the y-intercept, where it crosses the y-axis. So what I want you to do is take all 6 of these equations and put them into slope-intercept form. That means take the equations and solve for what variable? Y. So take all 6 of these equations, please, and solve them all for y. I'm going to give you like maybe 6 minutes or so to do that. Try that on your own. Then we'll go over them together and make sure you have those correct before we move on to the next part of the exploration. So take all 6 of them and solve them for y, which then essentially puts them into slope-intercept form.
Yeah.
You told me to put 3x first.
Yes. 2x first in this equation.
Oh.
Because 6 divided by 4 is 3. And then you keep doing things like this.
All right, hopefully that gave you enough time to at least get started on most of these. If not, we're going to go over the answers. Please follow along and write them down. So for letter A, to create this equation and put it into slope-intercept form, what we're going to do is solve for y by first moving all of the x numbers to the other side. So I'm going to subtract both sides by 3x. I get 4y equals, I'm going to rewrite the negative 3x first, so it's negative 3x plus 6. And then to get rid of the 4, I'm going to divide everything by 4. When I do that, I'm going to get that my equation is y equals negative 3/4 x, and then 6 divided by 4 doesn't work out evenly. It's just 1.5, so I'm just going to keep it in decimal form since it's easier than like a mixed number or an improper fraction for y-intercepts. So that first equation ends up being y equals negative 3/4 x plus 1.5. The second equation, I actually have to do the same exact couple of steps. I subtract both sides by 3x, and then I do the same thing. Write the negative 3x first, and I divide by 4, and I get a very similar equation. This equation ends up being y equals negative 3/4 x plus 3. And then the last equation here on this side, I'm going to solve this one for y as well. So this one's a little bit different. I'm going to subtract both sides by 4x this time. And I get 3y equals negative 4x plus 12. And then also I have to divide by now the number in front of y, which is 3. When I do that, I'm going to get y equals negative 4/3 x, and then plus 4. So what this is asking us to do is first rewrite all of these equations in slope-intercept form. I'm going to do these first 3 because these are the 3 we're analyzing, and then we're going to use the graphing calculator, and then I'll come back to the next 3. So it's asking us to use a graphing calculator to graph these 3 equations in the same viewing window. So I know that not everyone has graphing calculators. Here's what a graphing calculator looks like if you don't have one. They are like around $100 or so, maybe more, so they're very expensive. I can tell you that I got mine when I graduated from high school because my high school one that I had from, I don't know, I don't think I got it new, but it didn't last very long. So I had this since 2008. I'm still using it. It's not the coolest one. The newer ones are colored. So when you like do things like what we're doing today, they'll be colored. But what's really cool is there's a free app that you can download on the Apple Store or Google Play. It's called Calculate 84. And it takes your phone and turns it into a graphing calculator. Let me show you. So some of you might be thinking, well, I'm not downloading that, and that's fine. You do you, but everything that we do at this point in class can be done right with a graphing calculator. So right now I opened up the app, and it turned my phone into a graphing calculator, and it's free, so it doesn't require you to have one. But if you do have one, then I'm telling you it's a great investment. You'll use it throughout your whole high school career. You'll use it throughout college until you don't have to take math anymore. I promise you that. But until this time, if you don't have the money to just go drop $100 on a calculator for algebra, use this free app. I promise you I'll let you use your phone for the application of it when we do equations and stuff, and it works just as fine. So what we're doing is we're going to take all three of these equations and we're going to graph them using the technology instead of doing them by hand on graph paper. To get to the location that we need to get to, you go to y equals. And all of these things here say y1 equals, y2 equals, y3 equals. This is just giving us all of the different spots to insert our equations. So the first equation is going to be y equals, and we're going to type this one in, negative 3 divided by 4 x plus 1.5. And then to scroll down to the next equation, I'm going to type in the next one, which is negative 3 divided by 4 x plus 3. And then to scroll down and go to the next equation, this one is negative 4 divided by 3 x plus 4. Once I have these three equations in my y equals screen, I can see that this first one, since this is the newer version, it's colored. So this first equation line is going to be blue because it has a blue thing here. So I'm just going to highlight that this one's going to be the blue line. The second one's going to be a red line. Oops, that's not red. The second one's going to be the red line. And then the last one is going to be a black line. So when I go to see what this looks like in graph form, I hit the graph button, and I see all three of the lines graphed there in my screen. And if you're using the one on your phone, I can just show you really quick on Zoom if you guys can see that. And then for those of you here, it looks the same way as it does on the graphing calculator, which this is a free app. Just takes up storage on your phone, obviously. So, looking at these three equations, I can tell, just by looking at them, that two of the equations are parallel, and one of them is not parallel to the other two. Which two colored lines are parallel? Yes, the blue and the red lines are parallel. So, these two equations here are the ones that are parallel. So, this one and this one. I can tell from looking at the picture here that these are the ones that are parallel because I can see they have the same steepness and they don't cross. I can see that the black line crosses through both of them, which makes that not parallel. Let's look at the actual equations here. The two equations that are parallel are the equations y equals negative 3/4 x plus 1.5 and y equals negative 3/4 x plus 3. What do you see that is similar in both equations? They share something that's exactly the same, and what is it? The fraction, the negative 3/4. And what does that number represent?
The slope.
Yes. Both of these equations have the same slope, which doesn't that make sense? If lines are supposed to be parallel, that means that they should be the same exact steepness. That's what slope does. It gives a steepness for the line. If they have the same steepness, then they won't ever cross. They won't ever intersect. So we are then going to look at the same thing again, but for these three equations over here. So I'm just going to quickly take these and put these into slope-intersect form, and then graph these in the same y equals screen. So when I solve this one, so I'm not going to show all the work. I'll just tell you what the answer is. When I solve this one, it's going to be y equals negative 5/2x plus 3. When I solve this one, it's going to be y equals negative 2x plus 3. And when I solve this one, it's going to be y equals negative 2.5x plus 5. I'm going to put these in the same order as I did the last one. So when I go to graph this one, will be the black line. This one will be the red line. And this one will be the blue line. So again, if you don't have a graphing calculator, you can download Calculate 84, that app. It's like a pink app, and it changes your phone to a calculator. If not, then you just follow along for now. And I'll go to the y equals screen, clear these, and press down to clear out everything that I already had in there. And then go back to the top again. And now I'm going to put in these three equations. Y equals negative 5 divided by 2x plus 3. And then hit down. Negative 2x plus 3. Hit down. And then negative 2.5x plus 5. Now when I hit graph, I can see three new lines. These are kind of harder to tell from the way that it's like zoomed out and it's hard to see. If you look closely, you might be able to tell. You can also use the different functions, which as we use our calculators more, you'll understand these little options more. If you hit the zoom button and go down to zoom in, which makes sense, it'll zoom in for you. You just have to hit enter. We can see this a little bit clearly, that which two lines are parallel. Yeah, so the blue one, and depending on the colors, your third, is yours black? Okay, this one is too. So this one, the blue and the black ones, so the blue, the first one, and the last one here, the blue and the black line, are parallel. Looking at these two parallel lines, look at their slopes. Negative 2.5 and negative 5 over 2 equals negative 2.5. It's just in a different form. So they have the same exact slope. So equations that are parallel have the same exact slope. Easy enough. Flip over to the next page. We're not going to be able to finish the perpendicular lines. So flip over to page 31 really quickly. We'll start with perpendicular tomorrow, but on page 31 it looks like this. It says, what did you learn? The first question is something that we can answer really quickly. So I want you to take a minute. Please write down a sentence that answers the question, how can you tell the two lines are parallel by looking at their equations? All right, so how can we tell two lines are parallel by just looking at their equations? Perfect. The answer is they have the same slope, and we know that they are going to be parallel then. So you don't need to graph them. You can actually just tell from their equations if they have the same slope, then they are going to be parallel. So the last thing I want to just end with really quickly is this example number 1. Just bear with me. I'm going to kind of try and go quickly through this. We're going to do one more problem today to end the class, and we're going to be creating an equation of a line that passes through this point and is parallel to this line. This line has a slope of what? Yes, this line has a slope of negative 2. We want to create an equation that's parallel to that line. If that equation has a slope of negative 2, what should our slope be? Yep, our slope should also be negative 2 for our new line. That's because parallel lines have the same slope. So we want to create an equation, and it has a slope of negative 2, and it passes through the point 5, negative 4. Out of the two formulas we know so far, what formula is the easiest to create if we have the slope and we have a point? Yes, not a trick question. Point slope formula. So the formula for point slope is y minus y1 x1 equals the slope times x minus x1. So, since we know that the slope is -2, and this is the point that we're going to be passing through, we could just create the equation to be y minus -4, which would be y plus 4, equals the slope of -2 times x minus 5, and that would be the equation of the line that passes through 5, -4, and has a slope of -2. Yep.
Can't you also do the equation that's like, it might be slope form, but
Yeah.
I don't know, it's where you like put -4 equals 2 times 5.
Yes. If we use slope-intercept form instead, then what we would do is we would have y equals -2x plus b. We would put in -4 for y, and we would put in 5 for x, and solve for b. -2 times 5 is -10, so this would say -4 equals -10 plus b. We would add 10 to both sides, and this line would cross at 6 on the y-axis, so the equation would be y equals -2x plus 6 as well. So it doesn't matter which way you do it. Both of these equations represent the same exact line, just whatever makes the most sense to you because they didn't tell you which one to use.